Hello everyone, welcome to the new session. In today's session, we are going to talk about real number system. Okay, so uh, from this session, we have started the calculus. Okay, because to understand the calculus, we have to work out the functions, and to work out the functions, we have to understand real number system. Okay, so this is going to be the foundation. Now, this session and the coming few sessions are going to be the foundation for calculus. Okay, so let's start with real number system. Okay, so see here, uh, when we spoke about real number system, when we spoke about real number system, uh, in real number system, uh, we talk about all other numbers. For example, we talk about natural numbers, we talk about whole numbers, we talk about integers, we talk about rational numbers, we talk about irrational numbers, and then when we collect all these numbers, then in the end we got the real number. So we are just going to start with the natural numbers, and then we proceed step by step to get to the real numbers. Okay, so let's start with the first thing, that is our natural numbers. Okay, natural numbers. Now see here, uh, natural numbers, the set of natural numbers is represented by n. Okay, so here I'm just writing that uh, represent set of of natural numbers represented by n. Now see here, what are natural numbers? So natural numbers, basically, it's a collection of all the counting numbers, or I can say that natural numbers, it is the set of counting numbers, 4, so on up to infinity, right? So natural number, it is defined as the set of counting numbers. Okay, so here I can represent natural number as 1, 2, 3, 4, so on, right? So this is defined as the set of the natural numbers. Okay, now see here, if you look at this set of natural numbers here, I have said that the set of natural number, it is collection of all the counting numbers. Okay, but for example, let's say that I have 1 pen, I have 2 pens, I have 3 pens, I have 4 pens, but what if I have none, right? Then that element is not defined here in the natural numbers. So this has led us to the concept of whole numbers, which is nothing but whole number. So which is nothing but it has only one additional element, 0. Okay, so if you add one more element to this set of natural numbers, it will become the set of whole numbers. Okay, first of all, it is represented by, okay, the whole numbers set is represented by w, right? W, and I can say that W, it's going to be 0, 1, 2, 3, 4, and so on. Now see here, sometimes we also call whole numbers as non-negative integers. Okay, there is a reason why do we say that. Okay, for example, let's try to understand it on the number line system. Okay, so let's say here I have a number line. This end represents minus infinity, this represents plus infinity. Here I have 0, here plus 1, plus 2, plus 3, plus 4, so on. Minus 1, minus 2, minus 3, minus 4, minus 5, and so on. Now, it says that because I know that whole number means that natural numbers, and we just add 0 to the set of natural numbers to get the whole number. So, means that this portion represents your whole numbers, right? Then, but we also call whole numbers at non-negative integers. Okay, so why? Now see here, the reason behind it is that 0, this number 0, this is neither positive nor negative. Okay, so 0 0 is a number. It is just a number. It is neither positive nor negative. Okay, on the right side of the 0, okay, I have set of positive integers. On the left side of 0, I have set of negative integers. I hope everyone knows that, right? So it means that here uh, here here it represents negative integers, and here on this side it represents positive integers, right? But now all these integers on the left side of 0 contains the negative integers. Okay, so if I have to say that what are non-negative integers, you would say 0 and all on the right side of 0. Why? Because 0 we considered neither positive nor negative, but now we are talking about non-negative. So non-negative means that which are not negatives, right? So it means, so non-negatives is going to be this one, okay, including 0, okay, including 0. So I'm putting a dot on 0, okay, I'm putting a dot on 0. It means that this is going to be 0 to infinity. Okay, so 0 to infinity, it represents your non-negative integers. Okay, so that's why we call it whole numbers are also known as non-negative integers. Okay, but remember, 0 is neither positive nor negative. So this side is negative integers, this side is positive integers. So if this side is negative, so if we have to talk about non-negative, of course positive is non-negative, but 0 is also non-negative. Why? Because 0 is neither positive nor negative. I hope you understand what I'm trying to say. Okay, then go to next concept of, then the next comes is integers. Okay, integers. Okay, now integers, everyone knows that integers, it is represented, set of integers is represented by z or I. Okay, so integers are represented by z or I, and then here integers, okay, here I can write I is equal to, let's say, minus 2, minus 1, 0, plus 1, plus 2. Okay, this set it is the set of integers. Why? Because I have negative integers and then I have positive integers too. Okay, now see here, if I have to represent, okay, again, this is 0, okay, this is 0. Now 0, I have said 0, it is neither positive nor negative. Okay, so on this side of 0, on this side of 0, I have positive integers. Okay, and on this side of 0, I have negative integers. Okay, so on the right side of 0, we have set of positive integers. On the left side of 0, we have set of negative integers. Okay, now see here, negative integers, these negative numbers are important too. For example, now their uses are quite prominent when, for example, in terms of banking, if you look at your account books, okay, if you have account with any of the banks, and if you look at the account book, sometimes it represents the negative balance. Okay, negative balance means, for example, if there is a negative balance of minus $200, okay, which your account reflects, it means that you have to pay this much of money back to the bank. Okay, so whenever money shows up in your account, then the bank automatically deducts $200 from your bank account. Okay, because your right now your current balance in your account is $0, and bank and because you borrowed too, because bank charge you for the services, it means that as of now you don't have any money in your bank account. So how has that fees been deducted? Because bank has paid for it, so you need to pay it back to the bank. So that's why it says minus 200. Okay, so their uses, the use of negative numbers, it's quite popular when it comes to money. Okay, then next, number 4. Number 4, we have number 4, I will write it here. After integers here, number 4, after integers we have rational numbers. Okay, rational numbers, rational numbers. Now see here, rational numbers are very important. First of all, rational numbers are represented, they are represented by Q. Okay, the set of rational numbers is represented by Q. Now we will try to understand what does it mean, rational numbers. So see here, so any number of the form P by Q is the rational number if Q is not equal to 0. What does it mean? It means the rational number are of the form P by Q for all Q is not equal to 0. Why? If Q is going to be 0, then this is going to be not defined. Okay, so we have to make sure, like all those numbers which can be written in the form of P by Q for all Q not equal to 0 are the rational numbers. Now see here, if you ask me that what about this number, yes, this number is rational number. Why? Because here it is in the form of P by Q. Is P integer? Yes. Is Q integer? Yes. Is Q not equal to 0? Yes. So it means this is your rational number. Rational number. Okay. For example, 0.55. Okay, 0.55, it can be written as 55 by 100. Is 55 integer? Yes. Is 100 integer? Yes. Is Q not equal to 0? Yes. So this number, it's going to be rational number. Rational number. Okay, then if you ask me what about this number, for example 0 0.5 sorry 0.55555, okay, and I put bar here. Okay, so the bar here on the 5 means that that this is non-terminating and it is recurring. Okay, if you look at this number, see here, what does it mean? Okay, so the bar means it is not terminating, not terminating means that this does not stop here, right? This bar means that this 5 keeps on repeating, okay, and it also means that it is recurring, okay, recurring. Okay, now if you ask me what about this number, is this a rational number, I would say yes. Okay, now just uh, just think practically. Okay, let's say that, okay, I represent this number by x. Okay, x is 0 0.55555, okay, and so on, right? And now here I said 10x it is. Now see here, if x is this, then 10x it's going to be 5.55555, right? And so on, right? Because this is non-terminating, so it will keep on going forever, right? Now, if I minus both these, if you subtract both of them, subtracting, then what will you get? You will get 9x equals 5, okay, and which says x is equal to 5 by 9, okay, so 5 by 9. So what does it mean? It means that this thing x, see here, what does it mean? It means that this number x, it can be written as 5 by 9, which is of the form p by q, where p is integer, q is integer, and where q is not equal to 0. So this number is rational number, right? So whenever you come across these kinds of numbers having the decimals where after decimal you see non-termination and recurring. Okay, so what does that mean? If after decimals you see you come across the digit, or okay, you come across the number where after decimal you say that, oh, this thing is not terminating, okay, and it keeps on repeating itself, it has a pattern, okay, then that number can be represented in the form of p by q. So this is important, you must know it. So whenever you come across this kind of questions, just always think, just check for these two things, non-termination and recurring nature. If it follows, then it's a rational number. So I hope this thing is clear to you. Okay, then next thing is our our irrational numbers. Now see here, rational numbers, irrational numbers. Irrational numbers are number 5. We have irrational numbers, right? Irrational numbers. Now irrational numbers, what's the thing with irrational numbers? Now, irrational numbers are the numbers that you cannot represent in the form of p by q. And irrational numbers, the set of irrational numbers, it is represented by p. Okay, the set of irrational numbers is represented by p, and irrational numbers are the numbers that cannot be represented in the form of P by Q. Okay, so the example I would say pi. Okay, pi E. Okay, now see here, this E here, it is Euler's number, right? Euler's number. Okay, because when we did exponentials and logarithms, especially exponential, we have derived this number. Okay, this is irrational number because why? The value is, okay, the value is 2.731828, and it just goes on. Now see here, the thing with irrational number is, or for example, you can also take the square root of 2 or 3. Okay, so these all are irrational numbers. Why? Because if you look at this, then after decimals you will say that this number, it is non-terminating because it doesn't stop here, it just keeps on going on and on and on, and at the same time it is non-recurring. Okay, non-recurring means that you cannot deduce any pattern after the decimals. Before, you remember in rational numbers, when we spoke about non-termination and recurring, we said that we put bar on the 5, means that we know there is a pattern, means that this 5, it keeps on repeating itself, or it could be 137 137 137 137. So that also means non-terminating and recurring, because you know something is, and something is repeating, and what is repeating, you know. But here it is very here you have no idea what's going to be the next digit, and here every time you go to the next digit, it's going to be the new one, means that of course the digit is going to be any digit between 0 and 9, but you have no idea, means that you cannot deduce any pattern here. Next digit could be 7, then next digit could be 1, then next digit could be 5, then next digit could be 9, then next digit could be 3, then next digit could be 2. So you cannot deduce any pattern which keeps on repeating. Okay, so that's why we call them non-terminating and non-recurring. Okay, so they are irrational numbers because we cannot represent them in the form of P by Q. Okay, so same here for pi. Now you can say that you are saying pi is irrational number, but uh, more often we have used pi as 22 by 7. Now this is not the exact, it is not the exact value, right? It is not the exact value of pi, it is just the closest value to the exact value that we take in order, that we take for the sake of convenience to solve the questions. But that is not the exact value, that is not the real value, that is just the closest value. Okay, so I hope you understand this. Okay, so just remember, irrational numbers, you cannot represent these numbers in the form of P by Q. Okay, then after irrational numbers, then we have real numbers, right? After irrational numbers, we have real numbers. Now real numbers, the set of real numbers is represented by R, right? R, represented by R. And then we have two types of real number: positive real numbers. Okay, positive real numbers represented by R plus, and then we have negative real numbers represented by R minus. I hope you know this. Okay, so from here, from all these 6 set of numbers that we have written, so I can say that this real number set of real number, it is the biggest set among all the sets of number written here, okay? But it is not the biggest set of numbers in math, okay? We'll come to that later, okay? Now, see here why I'm saying that. Now, why I am saying that. If you look at, if you look at, if you look at the number line, this is 0, okay, and here this is plus infinity, this is minus infinity, okay. So anything after 0 or towards this side, we have we have positive real numbers, and anything at this side we have negative real numbers, okay. Now uh, you can include all those numbers in within within these real numbers, right? For example, this line represents positive real numbers on the positive side, negative real numbers on the negative sides. What about the natural numbers? Yes, we know natural numbers, they are the set of counting numbers. So this is 1, right? This is 1. So anything that includes 1, and after 1, uh, here I will put solid, okay, means includes 1. So this is your natural numbers, okay. Then what about whole numbers? Whole numbers means that same natural numbers, but here you have to include 0 too, right? So which means that this one, so this is your, this represents whole numbers, right? Then integers easy. On the on the on the this side, on the right side, we have positive integers. So here I can say positive integers I, and on this side we have negative integers, negative I. Okay, then rational numbers. Now rational numbers can come anywhere. For example, let's say that minus 10 by 3, 0.3. So this is here 0.3. So 10 by 3, it's a rational number. Minus 10 by, oh, this is plus 10 by 3. So it will come here. If it is minus 10 by 3, then it would have come here between 0 and minus 1. Okay. Then irrational number, for example, E, 2.731828, where it's going to be, this is 2, this is 3, so 2.73. So this shows E. Then real numbers, all this side positive, all this side negative. So you can see here that if you have real numbers mean the bigger pictures, and in bigger picture you can see the flashes of small things too, okay. Then uh, we can also make a tree from this, okay. Let's see how we can do that. So how we can do that, let's say that here on the top, I have here real numbers, okay, real numbers. Then here I have positive real numbers, and I have negative real numbers, okay. Then again, this will include what? This is going to be your rational numbers. Then here irrational numbers, right? And then from here you can again break it down to guess integers, right? So integers contains both the positive and the negative. From integers you can just go to whole numbers, right? Whole numbers, and from whole numbers get natural numbers. Natural numbers. Okay, natural numbers. Now see here, so among all the numbers, all the set of numbers that we have discussed, I would say that real numbers, it is the biggest set of all the numbers that are present here on the whiteboard, but it is not the biggest set among all the numbers in math. Okay, because same like real numbers, here we have imaginary numbers which we are going to talk in the coming times. And when you combine both, then we have complex numbers. Okay, so complex numbers represents the biggest set of numbers. We are going to do it in the coming times. Don't worry. Okay, so just remember that set of complex number represents the biggest set of numbers. Okay, but here how the things worked out. Okay, so a real number, basically it's the combination of all these things. Okay, or it is the collection of all these things. Okay, now see here, if I have to now, if I have to talk about the domain of the real numbers, so real numbers, they are represented by uh, R, and also their domain, it is also represented by minus infinity to infinity. Okay, positive real numbers, how we represent them, R plus. Now see here, so positive real numbers, I can represent them with see here, this is your infinity, this is minus infinity, this is 0. So positive means this side, right? So this is going to be 0 to infinity, 0 to infinity. Now see here, 0 to infinity. Why? Because 0 is neither positive and 0 is now negative, right? So here I did not include 0. There is also one other way to write it, or what I can do is that if from all the real numbers, if I minus this, okay, if from all the real numbers, if I minus this, means that minus infinity to 0. Okay, here I can include 0 because I will be left with this. Okay, so if from the set of real numbers, if I minus this, then it's going to be, then I'm going to get the set of positive real numbers. Okay, then for negative real numbers means this one. Okay, it means that from minus infinity to 0. Okay, or in other way, if I can also write it like that, from the set of real numbers, if I minus 0 to infinity, right? Why? Because here I'm including 0, so it means that from here it is excluded. Okay, I hope you understand this. Then rational numbers. Rational numbers we represented by what do we use to represent the rational numbers? Q, right? Q. And irrational numbers we represented by P. Okay, again for rational numbers, again from where they can go, from minus infinity, okay, from minus infinity to infinity, right? And then irrational numbers again, uh, because you can find it anywhere on the number line, so their domain is not the issue right here. Integers, now integers, we have positive and we have negative. For positive integers, again, 0 to 0 to infinity. Why? Because 0 is neither positive nor negative, and negative minus infinity to 0. Again, it can be represented in the form of the set of real numbers, minus minus infinity to 0. So this is positive, right? And for negative, this again r minus 0 to infinity, and this. Okay, so this is also another way to represent the negative integers. Whole numbers means that um, you have to include 0 and this one, right? So you can say here whole numbers means represented by w, and the domain is going to be 0 to infinity, right? 0 to infinity, or here you can say r minus minus infinity to 0, or I can say that it can also be written as r minus r negative, right? r minus r negative. So you are just going to get the positive ones, right? Then you have natural numbers. Natural numbers means 1, 2, 3, so on up to. So here can be represented by 1 to infinity. So that's how we can represent them using the intervals or domains. Okay, so I hope this is clear to you. Okay, next time we are going to talk about a few more things. So thank you very much. Bye bye.